we are seeing Poisson's distribution. We have seen the formula in last lecture. So probability of R is defined as e raised to minus z into z raised to R upon R factorial, where z is equal to n into p. It is also called mean. Z is also called mean. So next question I'm writing here. Write on the question. In a certain factory producing cycle tires, there is a small chance of one in 500 for any tire to be defective. The tires are supplied in a lot of 20. Using Poisson's distribution, calculate the approximate number of lots containing no defective, one defective, and 2 defective tires, respectively, in a consignment of 20,000 tires. Okay, it is clearly said here using Poisson's distribution. So we are going to use Poisson. So in Poisson's, we need Z first, right? So for that Z, we need to define first P. P is nothing but the probability of success. So first we should define success. So here success is, what is the success? Can you just define success? Calculate the approximate number of, means it is not the probability, it is what? Frequency, right? Number is a frequency containing what? No 1, 2, but what? Defective tires. So what is the success? What is the success? Am I audible to you?
Yes, ma'am.
Yes,
Right. So can you just define the success? Please define success. What is success here? A success is lots having defective tires. Is this the success?
Yes, ma'am.
Right. So can you define P? P is the probability of success. What is the probability of getting defective tires? What is P? What is P? Probability of getting defective tires. Come on. In a certain factory producing cycle tires, there is a small chance of 1 in 500 for any tire to be defective. So what is the probability?
1/500.
Right, favorable upon total 500, there is only one defective. So we got P. What is N? Read it.
20.
Right, the tires are supplied in a lot of 20. So N is 20. We can go with Z now. So Z is N into P. That is, write it and solve. How much is your Z? 20 into P is 1 upon 500. What is Z? Find that.
0.04.
Right, 0.04, correct. So now we'll use Poisson's distribution. So we have the formula. What is that? Probability of R is e raised to minus z, z raised to r upon r factorial. And how many questions are there given? Approximate number of lots containing no, 1 and 2. There are 3 different questions. So first question is no defective. What is R?
0.
Equal to 0. Very good. So put R is 0, we have Z and solve in this. E raised to minus 0.04 into 0.04 raised to R. R is 0 upon 0 factorial. Solve it. Tell me the answer of no defectives probability. On calculator, you are just writing E and then directly minus 0.04. Don't write raised to there. So what is the answer?
0.9960.
Right, 9697. Right? Next, second, one defective. One defective. What is R here? Condition
1.
1. So put there 1 R and solve. E raised to minus Z, Z raised to R upon R factorial. 1 factorial. Do this. What is the answer? Please check. So probability of R is 1 is, yes, 0.03. Correct. 3843 something. Very good. Next question is 2 also. So 2 defectives. What is our condition? Equal to 2, right? So probability of R is 2. E raised to minus Z, Z raised to R upon R factorial. Do this. Yes, what is the answer? 7.6
7.6863 into 10 raised to minus 4.
minus 4. Correct. So you got the probabilities, but it is not asked find the probabilities. It is asked calculate the number of lots. So means frequency is asked. So we can go ahead with the frequency. Therefore, number of lots having first no defective. How can we define frequency? N into
N
P,
into P of
right? So what is N? Capital N? In a consignment of 20,000 tires. So is N 20,000? So 20,000 into probability no defective. It was 0.9607. So what do we get? Find it. What?
19.21.
Right, 19,214. It is 20,000. So it is 19,214 tires. Means there are these many lots which will have no defective tires. Second, one defective. One defective is N. So 20,000 into probability of R is 1, which was 0.03843. Find this. 2 defectives also will need. So N into 7.686 into 10 raised to minus 4. What is second? One defective?
768.6.
Right, 768.6, but as it is frequency, it cannot be in points. So it is equal to 769, we can say. And here,
15.372.
15.372, correct. So it will be rounded up to, say 15, right? Correct. So these are the number of tires, means number of defective tires in a consignment of 20,000 tires. So just check whether you have asked probability or you have asked frequency. So if it is frequency, just multiply that probabilities by the total number. You'll get frequencies. Chalo, so we'll go to the next question. If 3% of bulb manufactured by a company are defective, assuming Poisson's distribution, find the probability that in a pack of 100 bulbs, first 0, second 2 bulbs are defective. Okay, first thing is success. Can you define success here?
Defective bulb.
Right, defective bulbs. Getting defective bulbs is a success. So your success is getting defective bulbs. Very good. So whatever is the question is your success. So here question is bulbs are defective. So getting defective bulbs is a success. P, can you define P then?
3 upon 100.
Right, 3% bulb manufactured are defective. So 3 by 100. That means 0.03. Right. What is N? Assuming
100.
Poisson's distribution, find the probability that in a pack of 100 bulbs. So is N 100?
Yes, sir.
Yes. We can go with Z now. It is given Poisson's distribution. So we'll need Z. Z is N into P. Can you just solve 100 into 0.03?
3.
3. So you get Z is 3. And by Poisson's, we know the formula also. Write it there. E raised to minus Z, Z raised to R upon R factorial. Okay. So now there are two different questions. We'll solve them. First is 0. Defective means R is 0. The second is 2. So R is 2. So first is 0. Means R is 0. Solve it. E raised to minus Z. Z is 3. 3 raised to 0 upon 0 factorial. What is the answer? I'll write second also. 2. Means R is here exactly equal to 2. So probability of R is 2. E raised to minus Z, Z raised to R, which is 2 upon 2 factorial. What is the first answer?
0.04978.
Correct, 0.04978. Very good. Solve second.
Zero 0.2240.
2240. Okay. So these are the probabilities, and yes, we asked probabilities only. So this is the answer. It is not number of find the number, just find the probability. So these are the probabilities done. Write the next question. A manufacturer of pins knows that on an average on an average 5% of his products are defective. He sells pins in boxes of 100, in boxes of 100, and guarantees that sorry, not more than 4 pins, not more than 4 pins will be defective, will be defective. In how many boxes? In how many boxes out of 1,000? Out of 1,000, he will meet the guaranteed quantity. The guaranteed quantity. So is it first probability or frequency question? How many boxes?
Yes.
Frequency, right? So first we should go with probability and then we can go ahead with frequency. So first thing is we need a success here. So what is the success? Try to understand the question and define success. A manufacturer of pins knows that on average 5% of his product are defective. He knows that. Okay, he sells these pins in a box of 100. So and he guarantees that not more than 4 pins are defective in that. Yes, there is a defective, but not more than 4 pins are defective in each box. He guarantees that. So in how many boxes out of this is capital N, he will meet the guaranteed quantity. Means what? To meet the guaranteed quantity. But what is the guarantee? He guarantees that not more than 4 pins are defective. So what is the success here? Guaranteed quantity, he will meet the guaranteed quantity. Means whatever guarantee has given will be fulfilled, right? But what guarantee has given? He guarantees that not more than 4 pins will be defective. So what is the success? Come on. Pins are defective. Is this the success? Come on. He will meet the guaranteed quantity, means in a box, or is it the success that in a box not more than 4 pins are defective? That can also be the success. You tell me now. But in general, here meet the guaranteed quantity is related to the pins and pins are defective is the success, right? So what is P? P is what? Probability that pins are defective. A manufacturer of pins knows that on an average 5% of his products are defective. So what is P? 5%. Right, 5%. 5% is 5 by 100. That is 0.05. What is N? He sells pins in a boxes of 100. So total are 100 pins there in a box. Now, is it given by Poisson's distribution? No, nowhere it is written use Poisson. So we are using Poisson's. Why are you using Poisson's here?
P is very small
Right.
and E is large.
Correct. As P is very small and N is large, very large according to this. So we use Poisson's. So Z is equal to N into P. So 100 into 0.05. So what is it?
5.
5, right? And formula also we are writing Poisson's distribution. That is probability of R is e raised to minus z, z raised to R upon R factorial. Okay, now condition. What is the condition? Now we need the condition. We have written that pins are defective is the success, but the question is he will meet the guaranteed quantity. Means what is the guarantee now? Not more than 4 pins are defective, not more than 4. Not more than 4. So what is that? Not more than 4 is?
R is less than or equal to 4.
Very good. Not more than 4 means it cannot be 4 or more than 4, but it can be not more than 4 ना, म्हणजे 4 पेक्षा जास्त नाही, म्हणजे 5 नाही, 6 नाही आणि पुढचं काहीच नाहीये. पण हे 4 पेक्षा कमी असेल आणि 4 ही असू शकतं. करेक्ट? सो इज दिस करेक्ट? R is less equal 4. Is this not more than 4? Yes. Now we'll go with the probability. So we have to solve this probability of R less equal 4. What the less equal 4 will have? Probabilities of?
0, 1, 2, 3, and 4.
Right. 0, 1, 2, 3, and 4. Can we go opposite? 1 minus. If we go opposite, we have to solve for greater 4. We start with 5, 200. Is it okay? No.
No, ma'am.
So we'll go like this only, right? So e raised to minus z, z is 5 into z raised to r upon r factorial plus e raised to minus z, z raised to r 1, 1 factorial. R now 2, R now 3, and R 4. Solve this and you can tell me answer. You can tell me direct answer finally. Please solve this. And it is not asked probability, it is asked how many boxes out of 1,000. So what is your capital N here?
1000.
Right.
1000.
Okay, good. Solve this first. Therefore, total number of boxes out of 1,000, he will meet the guaranteed quantity. Means not more than 4, right? He will meet the guaranteed quantity is equal to n into probability of R. But n is 1,000 into probability of that not more than 4. We are finding it.
Zero 0.4741.
0.4
741.
final answer you are telling?
Yes, ma'am.
Please check once again. I think. Please check it. 4, 4 we are getting because there will be a huge difference as we multiplied by 1,000. 4, 7 and 4, 4. Please check, all of you. So is the first 6.73 into 10 raised to minus 3. If you have solved it separately, plus 0.03368. plus 0.08422 plus 0.14037 plus 0.175467. If you have solved them separately. If you solve it together, please tell this. 0.44049. I'm getting this.
Yes, ma'am.
Right? It is correct.
Yes, ma'am.
And then right, then total number of boxes, total boxes are 1000. He will meet the guaranteed quantity. The probability of that guaranteed quantity is this. If we multiply by 1000, you will get the answer. So if you multiply by 1000, it will just shift 3 digits, so 440.49. But as frequency, you should round it up to somewhere, and you can either write 440 or 441. So there are such 440 boxes. Okay, is this clear? This is the probability, and we need to frequency, need to find the frequency, so we just multiply it by total number. Okay, so next question we'll see now. In a Poisson distribution, Poisson's distribution, probability of x is 2 is equal to probability of x is 3. Find mean and also find probability of x is 0 and probability of x is 4. Okay, this is the question. It is given Poisson's distribution and the statement. From that, you will find mean. Means what you have to find? Mean is what in Poisson's? Z, right? You have to find Z. So in a Poisson distribution, first we have a formula. What is that? Probability of R is e raised to minus Z, Z raised to R upon R factorial. But if you can see here, R is replaced by X, right? So generally we write R is equal to 0, 1, 2, 3, but here it has used X. So we can replace all R by X. So what is the formula? E raised to minus Z, Z raised to X upon X factorial. As X is there, if they use any other variable, we can change accordingly. So given is probability of X is 2, is probability of X is 3. Right? Means in this, we have to write X is 2 here and equal, we write X is 3. So e raised to minus Z, Z raised to X, but X is 2 upon 2 factorial. Is e raised to minus Z, Z raised to X, X is 3 upon 3 factorial. As they are equal, e raised to get cancelled on both sides. And we are solving this by Z. So if we shift it here, Z square and Z square will get cancelled. This 3 factorial will come up here upon 2 factorial and Z square will go there in denominator. Right? So here Z square and Z square get cancelled. Here is only Z. And what is 3 factorial upon 2 factorial? Check it. So we get Z is 3 factorial upon 2 factorial. Factorial is actually multiplication up to that number from 1. So 1, 2. 1, 2 into 1, 2 get cancelled. So Z is 3. Right?
Yes, ma'am.
That is your mean. So we got the mean. And such questions are important for MCQs, can be asked. if some condition will be given to you and they will ask you find mean or find any probability. So yes, mean is done. Then there is second question of also find probability of x is 0 and x is 4. Two questions. So now probability of x is 0, e raised to minus z, we have z now 3 into 3 raised to x, x is 0 upon 0 factorial. Can you solve this? Find the answer. Also, we have to find probability of x is 4. So e raised to minus z, z raised to x, x is a 4 upon 4 factorial. Solve these two.
0.04978 first.
0.04978. Right. Solve second.
0.1680.
1680. 3 something, right? Correct. So that such question can be asked. Everyone is clear? Next question. In Poisson's distribution, if probability of R is equal to 0 is 0.1. Find mean and probability x is equal to, R is equal to 1. Okay, something is given in Poisson's distribution. So we can use that Poisson's distribution. Probability of R is e raised to minus z, z raised to R upon R factorial, because we can see R there. So we are writing it in R only. We have something, but probability of R is 0 is 0.1. So here we can put R is 0. So we get e raised to minus z, z raised to 0 upon 0 factorial is equal to 0.1. Okay, we know this. Anything raised to 0, what is the value? 1. Right, and 0 factorial is also always 1. Right, 1 factorial is also 1. Okay, so these are some standard results. When this is 1, this is 1. So it is just e raised to minus z is 0.1. But we are interested in z. How can we? We want z, but it is in power of e. We have seen this. How can that z come down?
1 upon e raised to z.
Sorry? We have seen it somewhere like a raised to x.
Logarithm.
Right. Taking log on both sides. Taking log on both sides. What we get then? But as this is base e, so we should take ln on calculator, okay? Log is ln. If it is 10 raised to, then we take log. If it is e raised to, we take ln. Okay, so log, I can write ln. So it is ln e raised to minus z is ln 0.1. So now log and e get cancelled. Z comes down with the sign, so minus z. As log of e raised to something is that something only, this is the formula. Log of e raised to x is x itself. So log of e raised to minus z is minus z itself. Is ln 0.1? What is ln 0.1? Can you find?
Minus 2.302.
2.302. Again, one more digit. 2,
25.
25. Okay. Okay. Correct. So we need Z on both sides. Negative sign is there. Just cancel it. So 2.3025 is your Z, which is also called mean. So we got the mean. Now it is asked probability R is 1 also. So probability R is 1 means e raised to minus Z. We have Z now 2.3025 into Z 2.3025 raised to R 1 upon 1 factorial. Find it. Tell me the answer.
Zero point 2032.
0.2032.
6.
6. Okay. Just check. Correct.
Yes, ma'am.
Right. Correct. So such questions can also be asked in MCQ type, easier. Okay. So next is fitting of Poissons. We know how to solve by Poisson. So we now see fitting of Poisson's distribution. As like as binomial. We have seen there also. What you have to do is we have to find the frequencies by using probabilities. So we directly go with the question. Fit a Poisson's distribution to the following data. To the following data, and the data is given to you. Number of heads, which we'll call X. If not, you call it X. And frequency, which will be F. So number of heads and frequencies are 0, 1, 2, 3, 4, 5, 6, and 7. 7, 6, 19, 35, 30, 23, 7, and 1. Here we'll need capital N, right? If we start the solving question, but here we'll need capital N. What is capital N? What is capital N in such case? What is small n?
7.
What is small n?
7.
7. Right. And what is capital N? Summation F. Correct. Find out it. 128. Right. So capital N is a 128. And it is a Poisson distribution, means we can write the formula. E raised to minus Z, Z raised to R upon R factorial. Here, most important is Z, right? Z is N into P. We don't have P, so we need not have to write N, small n. But here Z is what? Mean. So we'll directly get the value of Z if you find the mean. So what is mean of this? X and F, if given, what is the mean?
Summation of X upon summation of.
Right, summation f x upon summation f. This is the definition I told you. So yes, it is summation f x upon summation f. Do this, Z is therefore summation f x, f into x. Summation means addition of all these f into x. So 6 into 1, 19 into 2, 35 into 3, plus 30 into 4, plus 23 into 5, plus 7 into 6 plus 1 into 7 upon summation f, that is 7 plus 6 plus 19 plus 35. We already have find this 30, 23, 7, 1. Okay, what is the numerator? Please find it.
433.
Okay, good. So we got here Z is equal to 433 upon summation f, which was 128. So what is Z?
3.3828.
3.3828. Again, 1.
125.
125.
125.
Right, take it. Because this is the value of Z, don't compress it. Chalo, then we have Z and we need this Z for finding probabilities. So what is your R now? 0 to 7. These are your R. So we start with first. R is 0. So it is e raised to minus Z into Z raised to R upon R factor. Find it? Tell me.
0.03395.
0.03395
What is answer? I'm sorry. What is the answer of this?
0.03395.
0.03395
3395. Okay, good.
180.
Okay, good. Chalo. Probability R is 1. Now it is there in your calculator. You just change this R. You just go back and change here 1 and here also 1 if it is there.
0.1148.
Just a minute. Let me write first. Raised to 1 upon 1 factorial. Yes, what is that? 0.11485.
11485
Aage?
26.
26. Good. Find probability R is 2. Let this in your calculator, this term, and just then replace that R. We are doing that only. Don't do everything 3.3828125. First fix it and then just go back and change this wherever 1, do it 2. Here is also 2. Yes, what is answer?
0.19426.
4 to 6. Correct.
25.
Okay, correct. Good. 3, 4, 5, 6, 7. All you need to solve. Probability R is 3, na? 3. E raised to minus 38281. Into 3.3828125 raised to 3 upon 3 factorial. What is that?
0.21905.
Good. Okay, chalo. Then you are writing this and tell me the answer. R is 4.
0.
Bolo. 0.525.
18525.
Good. Chalo. Next, R is 5. Replace there by 5. Yes, tell me.
0.12533.
3, 3. Good. Next, 6. Do it fast. Do you have calculator with you? everyone? Solve
Zero,
करो.
zero,
0.07066.
666. Okay. Next 7.
0.034149.
0.034
149.
149. Good. Chalo. So these are the probabilities. We'll need up to 7. We have solved. And now we are interested in frequencies. So expected frequencies. What is the definition? What is frequency?
Capital N into P of R.
Right. N into P of R. So we will first find frequency at 0. That is capital N. It is 128 into probability at 0. What was that? Probability at 0 was 0.03395. 0.03395. Can you just check this value?
4.3456.
Okay, so I'll write it here. F of 0 is equal to 0.03395 something into 128.
3456.
4.3456. Okay. F of 1. Frequency at 1 is probability at 1 into 128. Probability at 1, 0.1148. 526.
14.7011.
14.711.
Okay. 2. What was probability at 2? 0.19. 42625.
24.8656.
Okay, I have written 0.21905. 0.18525. 0.12533. 0.07066. And 0.034149. Okay, now we can tell me.
28.0384.
Okay, next.
23.712.
23.712. Very good.
712.
Next.
16.042.
Very good. Next.
9.0448.
9.04. Check once. Is this 0? And last one is
4.3710.
4.3710.
okay. So these are the frequencies, means cannot be in this form. So you will round it up to somewhere. You will round it up so that the total frequency will be again 128. Okay. So where will we round it up to? 4.
4.
Okay. Here it will be to 15.
15.
It will goes to 25. That will be to 28. This is 24. This is 16. This is 9. And this can go to 4. Can you just add them and see whether it is 128 or not?
No, ma'am. 125.
125 means 4 are less, right? So we have to round it up 3 numbers. So can we instead 4, can we write it here 5? It is up to you. So yes, 1 increased. This is okay. This is okay. This is also okay. Okay, 16 okay. 9.0 or here also increase anyone. So we'll increase 1 here and 1 here. So I can write it here 10 and here 5. So there is little error. It is okay. It is up to you to round up the things and make it 128. So it's up to you. You can either can go here and write it 17. Choice is up to you. Okay, therefore the fitting will be like R and F will be there. Whatever your X is your R now. So means 0, 1, 2, 3, 4, 5, 6 and 7. So at a 0 frequency is 5, 15, then 25, then 28, 24, 16, 10, 5. Yes, this is the required fitting. Does this number change from the original? Yes. It was 7, 6, 19, 35. Much changes are there. And it is okay that 1 here or 1 there. Like if it is 16, you write 17, and if it is 10 and you write 9, okay. That much is accepted. So this is how the frequency is. Like we have seen in binomial, exactly similar. Now we can take those questions also which we have solved in binomial and fit them Poissons. Try. If you want more questions, the questions which we solved in binomial can be taken ahead in Poissons and can be solved here. So this is all about Poissons. So there is only one distribution left, that is normal distribution. Please don't leave. Wait, I'll be taking your attendance. In between, if you have any question, any doubt, you can ask. Is there anything you want to ask? Go ahead. And just a minute.